Let's take a look at Wednesday's weekly math review, Q13. I will use the standard algorithm to multiply 937 times 12. I'm going to start with multiplying my ones place, that 2 times each digit.
Mama.
My final answer is 11,244. All right, let's go ahead and divide 288 into 8. If you look at the bottom of my screen, I have written those multiples for 8. I'm sure that you've already written it on your scratch paper. I can see that 8 can go into 24 3 times. So let me try 3. 8 times 3 is 24. I'm going to subtract. 8 minus 4 is 4. Bring down my 8, which is 48. I can look at my multiples and see that 8 will go into 48 6 times. 6 times 8 is 48. I'm going to subtract, and I see that my final quotient here is 36. So now let's find the sum of these decimals. If you've noticed, I've already lined up my place value for 65 and 53 hundredths plus 4 and 85 hundredths. So we'll start in our hundredths place, and we will add 5 plus 3, which is 8. 8 plus 5, which is 13. Carry my 1. I'm going to go ahead and bring my decimal down. 5 plus 4 is 9, plus 1 more is 10. I'm going to drop that 0, carry that 1. 6 plus 1 is 7. My final answer, my final sum is 70 and 38 hundredths. All right, so let's go ahead and find the difference of 126 and 78 hundredths minus 65 and 98 hundredths. I'm going to start subtracting in my hundredths place. I'm going to have to do some regrouping here. That means 2 slashes. That 6 becomes smaller. This 7 becomes a 17. I'll bring down my decimal. 5 minus 5 is 0. Here, I'm going to have to regroup again. I'm going to make that 1 less and that 2 a 12. 12 minus 6 is 6. And I see my final answer here is 60 and 80 hundredths. I could also write this difference by saying 60 and 8 tenths. Those answers would be the same or equal. So we're going to compare 678 and 5 hundredths by 67 and 805 thousandths. I can look at my place value here, 5th graders, and see that here I have 678 as a whole number, because we know our decimal is separating our whole numbers from our fractional parts. So I see that 678 is a whole number. And then my second number, 67, is my whole number. Just looking at those whole numbers alone, I see that 678 and 5 hundredths is greater than 67 and 805 thousandths. All right, so now we're ready to compare 30 and 30 hundredths and with 30 and 3 hundredths. So again, thinking about what we already know, we see that our whole numbers are the same. They are equal. So we're going to look at our fractional parts and compare those. We see in our fractional parts, we have a 3 in the tens place here, and a 0 in the tens place. We already see that this 3 in the tens place is greater than this 0. So our final answer is greater than. 30 and 30 hundredths is greater than 30 and 3 hundredths. All right, so I'm going to get ready to simplify 9 over 27. I know that 9 and 27 are both multiples of 9. So if you've noticed, I've listed my 9s, and I'm sure you've done that on your scratch paper. Once I've listed my multiples, I see a 9 and a 27. So I know for sure that I can divide both of these numbers by 9. And I'm going to divide if I'm simplifying or making that number smaller. So let's talk about what we already know. We know that 9 divided by 9 equals 1. And 27 divided by 9 is equal to 3. We have simplified 9/27 is equal to 1/3. We know that 1/3 is a unit fraction because there is a 1 as our numerator. Now we'll simplify 2 over 22. I know that this is an even number, and both of these are multiples of 2. As you can see, I've listed my multiples of 2, and I know that I can divide both of these by 2. 2 divided by 2 would give me 1. 22 divided by 2 would give me 11. 1 over 11 is my final answer. Do you notice anything about this simplified answer? Yep, you're right. It is also a unit fraction. We know that 1/11 is a unit fraction because there is a 1 as the numerator. So it has been simplified. All right, guys, now we are going to solve this expression using PEMDAS. PEMDAS is an acronym that'll help me remember the order of operations when solving my expressions. So here the P means parentheses, so I'll do my parentheses first. Exponents we haven't talked about yet. We don't have any exponents in this problem, but we will have some in the future. Of course, the M stands for, you got it, multiplication, the D for division, the A for addition, and the S for subtraction. So let's go ahead and take a look at this problem. We are going to first start with the parentheses. And as you see, I do have parentheses here as well as brackets. So I'm going to go deep inside of those brackets to solve 6 plus 6. I know that 6 plus 6 is 12. Once I solve that, I'm bringing everything down so that I can rewrite this expression. Once I've done that, I'm going to continue in my parentheses, or in this case, brackets. I'm looking at 3 times 12, which is 36. So I'm going to place 36 right here under this problem. I've already answered this problem, so I'm going to bring my subtraction sign down and the number 2. From there, I'm going to continue to answer this problem. 36 minus 2 is equal to 34. 34 is the answer to this expression. Please rewind and watch this segment if you think you missed a step. All right, so now we are going to draw a model to represent the following problem, 5 times 3. So here I could go ahead and draw out 5 groups. And now I will place 3 logs in each of the groups. If I were to count each of my logs, it would show a product of 15. So there are 5 groups with 3 in each group, which is equal to 15. So here is a model to represent 5 times 3. All right, so now we're going to label 7,854 and 209 thousandths. We're going to start by just labeling my place value. And there you have it. Great review today, guys. Please make sure that you have completed your weekly warm-up Monday, Tuesday, and Wednesday. Make sure that you reviewed those skills so that you are ready to test on Friday. See you tomorrow.